Hi everyone, welcome back to my YouTube channel. So today we are going to see some theory and numerical part of tacheometric surveying. So tacheometric is a branch of surveying to compute mainly the horizontal and the vertical distance here. So this method is mainly used to calculate the horizontal and vertical distance with the help of the angular observation. Now the method of tacheometric system, we have the stadia system, tangential system and substance bar system. In a stadia system, what do we have is diaphragm in this system contains only these two main horizontal hairs. In a stadia system, this diaphragm contains two main horizontal lines and then there are two stadia hairs. These are the stadia hairs. Let this point C. This will be the top reading, middle reading and the bottom reading. These two stadia hairs is placed equidistant above and below the main horizontal cross hair, and this distance between A to B is known as the stadia interval. That will be a I. Here now the difference between the stadia system and the tangential system is only that the stadia system contains these stadia hairs, whereas this tangential system, in this tangential system we have only the main two horizontal lines. There is no stadia hairs. And in substance bar method, when we have to calculate the distance, this is station A, on top this will be station B. So what will we do is we will put a substance bar here at line B, and then with the help of the angular observation, we will calculate the distance, this distance x. So this will be a substance bar, and with the help of this we will calculate the distance, this x. Now stadia systems have different two types, that will be the fixed hair method and movable hair method. So in fixed hair method we have I constant, we have stadia interval constant. Stadia interval here is constant, whereas in movable hair method this I stadia interval is variable. This is the only difference between these two, fixed hair method and movable hair method. Now the fixed hair method is further divided into two types, that will be the horizontal line of sight and inclined line of sight. We will only discuss about the inclined line of sight in this numerical video. So in inclined line of sight, it is further divided into two types, that will be the staff vertical and the staff normal. For both of these we will calculate for angle of elevation and angle of depression here. Today we will see a theory part and a numerical. We will also solve a numerical of a staff vertical to inclined line of sight for the angle of elevation and angle of depression. So now here we are going to derive a formula to calculate the horizontal distance between the instrument and the station, and also the vertical distance between the instrument line of sight and the middle reading. So here when the staff is vertical for the inclined line of sight, we have draw a figure here. If you guys can see in the figure, this is the instrument station, this for angle of elevation, this is for the angle of depression to the lower side when the staff is to the lower side. Now here theta is the angle of elevation or angle of depression, depending upon the conditions here. Theta here is between this middle hair reading. So in this stadia system we have these two are the main horizontal lines, and these are the stadia hairs. This will be A, B, and this middle reading will be C. This is the top reading, then middle reading, and then the bottom reading. So theta is angle derived from the line of sight to the middle hair reading. S is the staff intercept, that is AB. Then we have alpha. Alpha is the angle between the two extreme rays, that will be the top and bottom reading. Now L is inclined length, OC length, this OC length, the inclined length. Here H is the distance between the middle hair reading to the instrument station E. This is E is the instrument station, whereas O is the optical center here. Now we have D is the horizontal distance between these instrument stations and the staff station. Now V is the vertical distance between the middle hair reading to the line of sight. All these are same for this angle of depression 2, only the position of VH will be different according to their position. So now we are going to derive the formula for the horizontal and the vertical distance and elevation formula for the inclined line of sight. Now here right angle triangle, this OFC, we have angle COF, angle COF is equal to theta, and angle OCF will be equal to 90 degree minus theta, since this is also 90 degree here. Now we have angle BCB dash will be equal to angle ACA dash, which will be equal to theta. A dash B dash is perpendicular to OC here. Since this BCB dash, this is theta, the opposite side is also ACA dash is also theta here. So here now in triangle A dash OC, this triangle, we have this A dash OC, this angle, this total angle is A dash OB is alpha, so this half will be alpha by 2. So angle A dash OC is equal to alpha by 2. Now we will find this angle, that will be angle CA dash O. So CA dash O will be equal to 90 degree minus alpha by 2. So this is a simple geometry. If you know the geometry, you can easily calculate this. Since this is angle, this will be x. So what happened here is x plus this is 90 degree. So x plus 90 degree plus this angle is alpha by 2 will be equal to 180 degree. The sum of all interior angle is equal to 180 degree. That's why x will be here 180 degree minus 90 degree will be 90 degree minus alpha by 2. So angle CA dash O is 90 degree minus alpha by 2. Now we are going to find this angle A dash CA dash A. So here angle CA dash A. If this is a straight angle here, this is A dash, this is 90 degree minus alpha by 2, and this let angle Y. So Y plus 90 degree minus alpha by 2 will be 180 degree from the straight line of geometry. So this will be 180 degree minus 90 degree will be 90 degree plus alpha by 2. Therefore CA dash A here is 90 degree plus alpha by 2. Since when K is equal to 100, we have this alpha, we assume alpha very small, which can be negligible. Hence the triangle A dash C and B dash C can be assumed as a right angled triangle. Hence triangles A dash C and B dash C may be assumed as right angled triangles. So here B dash C is equal to angle A dash C, which is equal to 90 degree here. Now from the right angle triangle, in right angle triangle A dash C and
B dash C. We have to find out A dash C and B dash C. So A dash C will be equal to AC cos theta. AC cos theta. Since here the longest side in a right angle triangle is assumed as the hypotenuse, this is a small triangle here, A dash AC. This is theta. So the longest opposite to the angle is perpendicular. This must be the longest side assumed as the hypotenuse, and this must be the base. So for cos theta we will have B by H, which is A dash C by AC. So A dash C is equal to AC cos theta, and sin theta we have formula P by H. So from here we will also calculate B dash C and A dash C. So A dash C is AC cos theta and B dash C is equal to BC cos theta. Let us assume this as equation first and this as equation second. Adding equation first and second, we have adding equation first and second, we get A dash C plus B dash C is equal to AC cos theta plus BC cos theta. So A dash C plus B dash C is total A dash B dash. A dash B dash is equal to AC plus BC, here is AB, that will be AB cos theta. Mean here we have to find out this, the horizontal distance and the vertical distance V. Inclined length L is equal to, here the inclined length L is OC. Previous theory we have inclined length or any horizontal distance T is equal to KS plus C, whereas S is the stadia intercept, K is the multiplying constant and C is the additive constant. K is mostly 100, where the value of K is 100 and C is between 0.3 to 0.6 meter. So now we have for the inclined length L, we have K, whereas the stadia intercept here is A dash B dash. For this inclined length L, we have stadia intercept is A dash B dash. A dash B dash plus C. Now we have A dash B dash is equal to, A dash B dash is AB cos theta. So K into AB cos theta plus C, whereas AB is the stadia intercept as KS cos theta plus C. Now in triangle OFC, this triangle OFC, in triangle OFC we have the horizontal distance T. This distance T is equal to L cos theta. Since this is theta, this will be the base, and this is perpendicular distance P. So in triangle OFC we have D is equal to L cos theta, whereas inclined length L is KS cos theta plus C into cos theta, which will be equal to KS cos square theta plus C cos theta. So this is the formula for the horizontal distance. This is the formula for the horizontal distance when the staff vertical to the line of sight is given. Now for the vertical distance, again for the vertical distance V, For vertical distance V, this V, whereas V is the distance between the horizontal line of sight to the middle staff reading. This is equal to L sin theta. L sin theta, which will be equal to K as cos theta plus C into sin theta, which is equal to K as cos theta into sin theta plus C sin theta. So we have formula for sin 2 theta, we have 1/2 sin theta into cos theta. So we get the formula here for the vertical elevation. We have V is equal to half K as sin 2 theta plus C sin theta. So this is the formula for the vertical distance when the staff is vertical to the line of sight. Now we have to find out the RL of the staff position, that is here this RL. So RL of staff position is equal to RL. So for this RL of staff position will be equal to this RL of the instrument station plus this height of the instrument. So we will go there. Then we have to add this whole V. In the there is angle of elevation, we will add V, but for the depression we will subtract V. So here for angle of elevation we have to add V, then we will subtract H from this, so we will get this point RL of the staff. That will be here RL of instrument station plus height of instrument plus minus V minus H. So positive for the angle of elevation and negative for angle of depression. Positive for angle of elevation and negative V for angle of depression. So these are the formulas for calculating the horizontal distance, vertical distance, and the RL of the staff positions. We will solve a numerical based on this theory. We are going to solve a numerical based on this topic. So the given numerical here is a staff was held vertically at a distance of 46.2 meter and 117.6 meter from the center of a theodolite fitted with a stadia hairs, and the staff intercept with the telescope horizontal were 0.45 meter and 1.15 meter respectively. The instrument was then set over a station P of RL 150 meter. The height of the instrument axis, this is HI, is 1.38 meter. The stadia hairs reading on a staff held vertically at a station Q were 1.2 meter, 1.93 meter and 2.6 meter respectively, while this must be the upper, middle and the bottom readings. So while the vertical angle were minus 9 degree 30 seconds. Find the distance PQ and RL of Q. Since here the angle is given as negative, the staff must be at the angle of depression here. Now here solution, we have for first setup of instrument, this is an instrument here. This is the line of sight. A staff was held vertical at a distance of 46.2 meter and 117.6 meter from the center of the theodolite, fitted with the stadia heads, and the staff intercept with the telescope horizontal were 0.45 meter and 1.15 meter respectively. So these are the staff intercept S1 and S2. So given we have S1 is equal to 0.45 meter and S2 is equal to 1.15 meter. Now they are the two staff held at a distance of a 46.2 meter. This is 46.2 meter, and the another one is 117.6 meter. 117.6 meter. These are the two readings here. So this is S1 and this is S2. And these are the two distance T1 and D2. Now we have, for a fairly level ground, we have formula D is equal to Ks plus C. Since there are two staff here held, we have general equation of tachyometer as D is equal to Ks plus C. When S1 is equal to 0.45 meter and distance T1 is equal to 46.2 meter. 46.2 meter, we have D1 is equal to K S1 plus C. So from the first instrument setup, we will find the value of multiplying constant K and the additive constant C. So here, when D1 is 46.2 is equal to 0.45 times of K plus C. Let this be equation first. And when S1 S2 is equal to 1.15 meter and D2 is equal to 117.6 meter, we have D2 is equal to Ks2 plus C. That is 117.6 is equal to 1.15 K plus C. This is equation 2. Subtracting equation first from second, we get 117.6 minus 14.6.2 will be equal to 1.15 K minus 0.45 K, since C will be cancelled out, or 117.6 minus 46.2 is 71.4 will be equal to 1.15 minus 0.45, which is 0.7 K. Therefore, the value of K will be equal to 102. Now we will find the value of C from equation first. So from equation first, we have 46.2 minus 0.45 times of 102 will be equal to C. Therefore, the value of C additive constant here is 46.2 minus 0.45 into 102. That is 0.3. Now from the first setup, we will find out the horizontal and the vertical distance, also the RL. Now for second setup of instrument we have the instrument was then set over a station P of RL 150 meter. So when the RL of P is given, which is equal to 150 meter, also height of instrument is given here, which is 1.38 meter. Height of instrument is equal to 1.38 meter. So since the angle was given in negative, so that must be the angle of depression. So instrument is set over P, the staff must be held here, that is the height of instrument. The stadia has reading on a staff held vertically at a station Q. So this point is Q here. So this is the horizontal distance, this is the line of sight, this is the reading from the instrument. So the distance between the line of sight and the middle reading is V. This is V, and this is height of instrument. RL of P is already given, and the staff intercept is also given, which is 1.2, 1.93 and 2.65. 1.93, 1.2 must be this, and this must be 2.65. The bottom must is low and then increasing. So this is 1.2, 1.93 and 2.65 is given. The distance between the staff held at the ground to the middle reading is H. Also theta is given as, this theta is equal to 9 degree and 30 minute. 9 degree and 30 minute. So we have formula. For the horizontal distance we have formula. This is the horizontal distance D of PQ. So horizontal distance PQ is equal to Ks cos square theta plus C cos theta, whereas K, we have calculated here the value of K, which is 102 in S is the stadia intercept, which is equal to top reading minus the bottom reading, which is 2.65 minus 1.2, which is equal to 1.45 meter. So this is 102 into 1.45 into cos 9.30 degree, 9 degree 30 minute square. C here is 0.3 into cos 9 degree and 30 minute, which will, so now we have 102 into 1.45 into cos 9 degree 30 minute square plus 0.3 into cos 9 degree 30 minute, which is equal to 144.17 meter. Now the vertical distance V is equal to 1/2 times 1 by 2 k as sine 2 theta plus c sine theta, which will be equal to 1 by 2 times of k is 102 into s is 1.45 into sine 2 into 9 degree 30 minute plus 0.3 into sine 9 degree 30 minute, which will be equal to 102 into 1.45 into sine 2 into 9 degree 30 minute plus 0.3 into sine 9 degree 30 minute, which is equal to divided by 2, which is equal to 24.1 meter. For the RL of, we have RL of Q is equal to, the RL of Q is equal to RL of PA plus HI. RL of P plus height of instrument. So we will go up to here. Minus V minus H. Minus V minus H. Which is equal to RL of P is 150 meter plus height of instrument is 1.38 minus V. V is 24.1 minus H, which is equal to 1.93. 1.93. This middle hair reading, which will be equal to 150 plus 1.38 minus 24.1 minus 1.93, which equal to 125.35 meter. So we get the RL of Q. This is all for today's video. Thank you so much for watching.